Hi my friends, today we model this part. You see that it has many interesting features. The drawing is this. We start by creating this contour, but including also this cut and this cut with these dimensions. New standard millimeters IPT, new sketch, XY plane, and we draw that half of the revolving part. Up, right, down, sloped, down, not perpendicular. This must be not perpendicular on the other line, so that I modify and I make it vertical. We continue with horizontal, up, right, down. We go here, here, and to this end. This is perpendicular. Okay. Angles are 5 degrees this one, and 5 degrees also this one. Coincident is this line with a center point. Then other dimensions. But firstly, let's create a center line. This is diameter 84. This is diameter 50. This is 15. This is 70 millimeters. Coincident is this line with the center point. Then this is diameter of 38, diameter of 26. The major dimension is 143, and this is 50. Good. What dimensions are missing? This one is 30, and this one is 3.2. Now we have a fully constrained sketch. Finish, revolve, and this is the first volume. Now we apply this chamfer 0.8 at 45. .8. Okay. Now this channels 8 of 6 millimeters around this center, 32 is one dimension and 38 is the other. We used 38 because we have this generator. Good. Select the face, apply project geometry of this external circle. Then we place our circle with a diameter 32 and we draw some lines between these two circles. 1, 2, 3. This last two must be parallel. This is construction, and it is coincident with the center point. And then I apply parallel. This dimension is half of 6. And this is with a dimension taken from the other, the 20. Now trim to eliminate this, this, and this. We need to use this closed contour. This is not important. I don't eliminate. Okay. Finish sketch. Extrude this area with cut to this face. Okay. Now we multiply this cut with the circular pattern. We select this feature, then we select this axis, and the number of channels is 8, not 6. Okay. We continue with this circular channel with dimensions diameter of 46, radius 4, distance of 4. To do this, the simplest way is to use this sketch, the first sketch. We draw a line horizontal, press the left button, go here and back. Okay, then we apply split in this X point and the other X point. Why? Because this is not useful when we apply revolve. Dimensions 4 millimeters, radius 4, and circle of 46 diameter. Finish sketch, and you see now that channel. Good. Other channels are this, you see, 4 channels at 45 degrees. 31 is the bottom and 16 is the width. Let's do this. We select this face, we project this circle, then we use rectangle 3 points, 1 point, 2 point, 3 points. This dimension is 16. We apply F7 to see the center point. Then we draw a line between this midpoint to the center point. Okay, and we apply perpendicular between these two. 31 is this. Or this. 31. The other the other side of the rectangle is now here. We move it up and we apply tangent. Then the 45 degrees. We need to draw a vertical line to here, for instance, and to apply the angle of 45. Here is a dimension needed. Why? Who knows? Because this is not an end, you see. To eliminate this, you can apply horizontal between this point and this point. Now it's fully constrained. It is better to use this to have no minus entities in your sketch. Okay, finish sketch, extrude this with or without extension. You see, you can select this or this. It doesn't matter which one. Let me use this as a cut and all the way through the part. Okay. Now we apply circular pattern of the last feature about this axis and number 4. You see, 4 channels. Now we have to create this countersink. 60 degrees, diameter of 6.7, diameter of 2.8, depth of 6. Where is in the center of the object. We apply hole, this option, and countersink option. This is 6.7. This is 60 degrees, not 90 degrees. This is 2.8. And the hole is not going through the part, but with a dimension. That dimension is 6. Where to be placed this? To be placed on this face. Where is the center? Here is the center. 6.7. My mistake. Okay. Other holes are here, these ones. They have a chamfer of 1 at 45. You see here 4 times of metric 8. Oh, this is my mistake. Double click and I eliminate this, hide the dimension value, and we place manually 8. Okay, now it looks nice. 4 times metric 8 equidistant. They are placed in vertical and horizontal axis. Good. We select this face. We apply a point right here on the same vertical with the center point and at a distance of 68 divided by 2. 68 divided by 2. Okay. Then hole, not countersink but threaded. Isometric profile, 8 is the dimension, and through the part is this hole. Okay, if you take a look here, you see this chamfer. We place that chamfer here, 1, not 0.8. Okay. Now we apply circular pattern for the chamfer and the hole. You select firstly hole and then chamfer. The axis is this. The number is 4. Okay. Good, good. At last we apply this undimensioned fillets radius 2. Where are they? This is one. This is another one. This is another one. If it doesn't have dimension, it is undimensioned. And here is also radius 2. We don't forget radius 1 here and radius 1 to both this. Okay. Let's apply this. As I said, this is 2 millimeters by default, plus this, this internal, and plus 1 millimeter, 1 for this, and this 2. 1, 2. Okay. I made a small mistake on this feature, circular pattern, and I want to show you what is that mistake. We have occurrences of 8 times. based on this feature. We don't have here the mark for fully constrained sketch, like for instance this one. You see here in this corner a small mark. Let's study this sketch. Double click and we don't see the angle. Where is the angle of 45? Nowhere. I select these two lines and I apply 45. This is why I didn't see, because it is very near 45. And now we still have one dimension needed. That dimension, I suppose, is this small line. We applied here a chamfer and we forgot to extend this. You see, we make coincident this endpoint with the center point. Now we have a fully constrained sketch. Okay, I go back with everything and let's see what is the volume. Properties, physical, update, and we select this value, copy, close, drawing, double click, and the new value is just the same. Yes, cancel. We keep one of them, no matter which one. Then we apply material. It is steel carbon. We also apply not default IBL but default lights, and now we can compare the two parts and we don't see any difference. Okay, that's all for today. Thanks for watching. Bye bye.